Alright, excuse the production quality, but I'm just going to go ahead and show you my setup for this two-stage BJT CE to CC amplifier. As you can see here, here's my circuit and everything that I hooked up. Currently using my DC power supply, using my fluke meter to measure an amperage across the load, my frequency generator, as well as the picoscope with my computer running the simulation of the oscilloscope. Real fast, some quick calculations. Lighting is a little bit horrible, but so here's my PSpice simulation. I'll go ahead and send you the actual file so you can look at it. These were the actual calculated resistance values and the CQ values and everything that I was going for, or the Q point values. I went ahead and put all different the actual resistant values that I measured, so there's a little bit of discrepancy between that and the calculated. But if you look on the sheet, you can see the actual measured DC values during DC analysis at VB, VC, and VE for both stages. Now back to the stuff you want to see. All right, so with this setup right now, I'm hooked up to the load, and I'm also arbitrarily hooked up to the base of, oh no, I'm sorry, that's the, yeah, the base, the input for the CC stage of the amplifier. This section here was the CE. One of the big things I found that I needed to do was I needed to increase the resistance on the base of the CE. Once I did that, that dropped the amperage going across that channel and actually started giving us good results. Without further ado, I'm going to go ahead and line up on the scope. So I'm going to turn on the 20 volts. You hear all the clicking of that. And then I'm going to actually turn on my signal generator. And let's see. Oh, all right. I had this happen to me before. I think my ohm meter is not working right. Let's see if by turning it off and then back on. Okay. Well, the easiest way to do this. Oh, my bad. Actually, I had the output turned off on my DC power supply. So let's see if I hook up my ohm meter, my amp meter to the fluke. This way we can, I want to show you the amperage that we're actually drawing. There you go. So the green waveform, which is actually I have it at 20 volts range. That's the signal that's leaving the base. Yeah, the signal that's leaving the base of yeah, that's the signal at the base of the CE amplifier. You know what? I'm talking and I'm out of turn here. It looks like that's the input signal to the CC stage. So that's going to the base of my BJT, but it's the second stage, the common collector. So that's my input signal. The green one is the input signal to the second stage, and the yellow signal is the output across the load. Now, right now, division-wise, I have it so you can really observe the load. But if I match settings, you can essentially see they're pretty much the same. And when I calculate it between the CE and the CC stages, you have an amplitude, you have a gain of 0.99, so we're almost dead nuts. Now, I am currently inputting a signal to the whole entire system at 20 kilohertz at 0.02 volts amplitude. Now that's actually, I've measured it, that's a peak to peak voltage. So if if you do the calculation, you can see, oops, let's get you a little bit better. Don't want to make this too long, but it's hard to see, but right now the yellow peak to peak is at 3.03 volts. You go ahead and do some math, gives you 43 decibel, or right around 140 volt. I mean, a gain of 140 voltage wise. So great. Now, one of the cool things is when we measure the amperage. So right now at a 2 volt range, I want to show you this. So go ahead and move the infamous cup that I'm using for a stand, and I'm going to load the production value. So as I increase my amplitude, you can see the current going up. Let me change the oscilloscope real quick. There we go. In fact, maybe I can get it side by side. That'd be so you can see everything. Sorry about this. Anyway, so you can basically see everything, and when I change the amplitude, you can see get an actual nice 3 milliamps, and then of course you can start seeing the clipping on the oscilloscope. If I go all the way up to 500, I have some severe clipping on the gate, but you can see we're coming up on 5 milliamps output. When I measure the input, I'm actually coming in at like 0.02 milliamps, so we're getting a decent gain. I believe I got the gain of 3 amperage, so not bad there, ultimately. So one thing I wanted to point out, did have some weird stuff happen. So you noticed I'm measuring the input going into the CC stage, right? That's this yellow wire right here. Well, if I unplug that, I get that infamous noise that we were seeing. Or, it's actually behaving today. You know what? I'm going to chalk this up to a fluke. Maybe I was doing something wrong. Earlier when I was doing this, if I would remove if I wasn't measuring this, you would see this massive noise spike. But it seems to be behaving, and I'm going to chalk that up as a win. So bottom line, got 140 volt gain. I want to show you this. I did calculate our 3 dB point. So if I go back to that 2 volt, you see I have a red line here, and I have another red line here. The second red line represents the 3 dB part, and if I reduce the hertz, which obviously we'll go ahead and change. So if I reduce you can already see we started attenuating, and when I get down to about 400 hertz, we got down to 3 dB, and that aligns up with there's 20. I did that test basically to show right here. This is this PSpice, by the way. There's your PSpice schematic. I don't know if that's going to come out well or not. Here's the Bode plot, and you can see right around there is where we got our nice 3 dB attenuation. But overall, that's what I did. Any questions? Hopefully I'll be sending you all the values so you can see everything. One thing that's super important with my frequency generator, I have to have this 50 ohm um, resistor because I do not have a high impedance function. So it's very, very, very critical to do that. Otherwise, I get some fun. Let's see. So if we look at the oscilloscope, if I actually go and short across, wow, this whole thing is really behaving. You know, last time I did all of this, I was getting some massive noise problems. One of the things I'm starting to speculate is if I leave the power on long enough and the capacitors charge, I tend to get a lot better results. Which, by the way, again, like I said in my text, that 220 microfarad capacitor, that has basically been the lifesaver and what changed everything. Because we were basically attenuating the bandwidth. Anyway, hopefully this helps.